Hey, fifth grade. Our objective for today looks a little longer, but there's a word problem right underneath it. So we'll start with this. I can divide 2 and 3-digit dividends by multiples of 10 with single-digit quotients and make connections to a written method. So it seems a little long, but what we're really doing is putting together some of our division skills with estimation skills and adding in a step you can see down here, estimate, solve, check, on how to check to see if we're right. So that's what we'll be working on today. We're going to start with an application problem where we're applying some of the old skills that we've learned into a word problem. At the Highland Falls Pumpkin Growing Contest, the prize-winning pumpkin contains 360 seeds. The proud farmer plans to sell his seeds in packs of 12. How many packs can he make using all of the seeds? So what we're really doing here is 360 divided by 12, right? We're putting those seeds into packs. I'm going to use some other strategies that we've practiced to break this problem up a little bit to make it a little easier for me to understand. So I can do 360 seems a little big. I'm going to break that up into 36 times 10, and then I still have to divide that by 12. Well, I can switch this around, so I can have 36 divided by 12, and then multiply the 10 after, because now I can do 36 divided by 12 is 3, and 3 times 10 is 30. You also could have set this up with regular long division, so 360 in here, 12 out here. You also could have thought, what's 36 divided by 12? 3, how many zeros are left? 1. Going into our actual skill practice today, let's look at problem 1. I wrote the problem in the middle under the solve column. So our division problem is 70 divided by 30. Before we can just jump in and solve it, we need to estimate. So the divisor is 30. We need a multiple of 30, like we practiced in our previous lesson, to make the division easy. How should we estimate this? Well, I'm thinking 30, 60. The next would be 90. 60 is probably the closest to 70. It's only 10 away. So I'm thinking 60 divided by 30. And 60 divided by 30 is 2. So our estimated quotient is 2. Which means that I should be able to distribute 2 times 30. So in our standard algorithm, we should be able to see that here. 2 times 30 is 60, and we subtract that and get 10. I don't have any other numbers to bring down. So this becomes my remainder. 10 over 30. 2 and 10 over 30. If I were to check that, I would do 30 times 2 equals 60. And then I add on this remainder down here. So 60 plus this 10 equals 70. Is that the number that we started with? Sure is. 70 is our dividend. So that's how we know we're right. Let's try problem number 2, 430 divided by 60. So the whole is 430, and again, we need a multiple of 60 to make the division easy. So it's going to be something divided by 60, and if I list out our divisor multiples, we'd have 60, 120, 180, that's times 3 times 4 would be 24 with a 0, 240, okay, 300, that's times 5, times 6, times 7. Oh, that's only 10 away. So 420 is going to be my multiple. And 42 divided by 6 is 7. There are no more zeros. So our estimated quotient is 7. There are 7 groups of 60 and 430, and then a little left over. So let's see if that's actually true. Let's record our 7 into the quotient. And it's recorded above the 0 because I'm putting 60 into this entire group. Okay, it represents 7 ones, so it has to be recorded in the ones place directly above the ones place in our dividend, in our whole. So 430 divided by 60, we're saying is 7, and there might be something left over. So 7 times 6 is 42, and 1 0. When I subtract, I get 10. Okay, so there's nothing else for me to bring down. This becomes my remainder. So I could say remainder 10, R10. As you get older, your answer would have to be written as a fraction. So we could say 7 and 10 over 60, or 10 over 6. I'm sorry, 1 over 6. And so now we have to check to see if we're right. So we did 60 times 7 equals 420. Then we have to add on the remainder. So 420 plus this 10 equals 430. Did we get the answer? Yes. When we're checking, we're looking to see that we get back to this dividend, this answer that we started with. Okay, so we'll do one more that is just like this, only the numbers are a little bit bigger. So now we have a 3 by 2. We're trying to make groups of 90 in this problem. So I'm thinking, what multiple of 90 is closest to 572? That would make this division easy. So I would need to list out 90 times 1 is 90, 90 times 2 is 180, 90 times 3 is 270, times 4, times 5. When I do times 5, I get 450, so we're getting closer. Times 6 is 540. Ooh, that's only 32 away. So 540 divided by 90 would be 6. That is going to be what I attempt to use here in my standard algorithm. So how many 90s are there? Or how many times does 90 go into 572? 6 times, and we record this above the ones place. And how many are remaining? Well, we need to subtract this out. So 9 times 6 is 54. There's 1 0 there. And when we subtract, there are 32 remaining. Is this enough to make another 90? No. And there's nothing else for me to bring down. So I can start checking. I did 90 times 6 equals 540. And then 540 plus this remainder, 32. That gives me 500. 40 plus 30 is 70. And then 2. 572, and that's what we started with. So that's how I know I'm right. Awesome. So you have 2 problems that I'd like you to answer on your own in your notebook before you start your practice problems. The first is, does it always make sense to use the standard algorithm? What about with a problem like 270 divided by 30? And then all of the divisors in this lesson were multiples of 10. Did this make the estimation easier? Thanks so much.